Hello everyone, my name is Guo Kaiyuan. My project's named Spatial Body. It primarily focuses on assisting upper limb rehabilitation for patients with motor impairments. So currently, rehabilitation patients face two main challenges. First, patients said that their rehab exercises and pain perceptions rely heavily on a physician's verbal instructions. There's a lack of an intuitive connection to their own physical movements. And second, highly detailed anatomical models are scarce. Very few physicians will use the physical plastic models to help patients visually understand their root cause. And our target users definitely the patients with upper limb motor impairments. This group of people shows a significant decline in the ability to process verbal instructions of the physicians. And additionally, many existing studies that relies on a wearable hardware for limb motion tracking, for example, the gloves. But most of them, these devices often struggle with sizing adaptability across different users, and their overall tracking accuracy is significantly low. And secondly, there is a current lack of virtual system that hosts the rich, interactive, and very detailed anatomical models. And also, the signal transmission latency is the persistent issue that can't be solved yet. There's exactly where spatial computing comes in. It enables intuitive human interaction within the virtual MR space. And our vision is to empower patients to understand anatomy through their own physical movements, even the most subtle movements. And furthermore, our research revealed that most of the physicians are eager to find some innovative communication and interaction methods with the patients that can increase their efficiency. And this the overall display screenshots of the app. I divided them into two modes. In the teacher mode, you can say the virtual model is overlapped on your own hands and can follow the very subtle movement of your hand. And for the patient mode, you are brought into a progressive immersive environment. In this field of view, you can see other users with another Apple Vision Pro that do the exercise demonstration in front of you. Okay, an obvious app flow is that I set the home page, and then you can select the two mode. In teacher mode, you come into the MR environment, and for patient mode, you will come into the progressive immersive environment that can see artist's hand. And in each mode, your task is quite different. Teacher mode, you can see your own hand and try to move some of the muscles and understand how this part can affect you, the whole palm, the whole hand. And for patient mode, you can see others' hand. And in this class, this project evolved through the several iterations. So at first, I tried to tracking my hand gestures with the MacBook camera and mapping the joints with some small balls, small spheres. But I quickly found out that the traditional camera, 2D camera, can't read depth, and one's hand's movement have lots of self-occlusions, so the accuracy was pretty low. And then I switched to ARKit's hand tracking that brought up a lot of spatial alignment issues. You can say the models here that cannot overlapped quite accurately with my own hand. And finally, I worked it out, and the project has been shown in the Spatial Singapore with some basic functions. And I also got many amazing feedbacks at these conferences. I had a chance to speak with many great people like Apple's developer relation lead, Jia. We had some great discussion about this, about the usability testing and what it takes to actual publish this app. Now there's a demo video. First is the teacher mode. You can see it's quite accurate, and the latency is not very high. And then the patient mode. In this patient mode, you can adjust the immersive degree by scrolling the digital Chrome. And for what I achieved, I think I have built a pipeline from a building anatomy model library and then make it interactive, and then integrate the multimodal medium, and finally to create many interesting functions in it. So first, I built the model, and in very detailed, I rigged it with skeleton and pinned the weight on it. Then I use many gestures as well as control panels to make it interactive in the virtual space. And then I want to do multi-layers interaction with models. You can say that different part you can highlight a specific muscle. And in the basement, I want to introduce the immersive videos that can show you the detailed movement, and the control panel can switch between them. And the final step that we can do the mirrored that can anchor the model in different place. You can do some connections between devices. The challenge I overcame, the first is the deviation between the virtual and real world. Even though I put the virtual model in the MR space, it can be influenced by my own movement, but it cannot align perfectly with my hand. You can see some direction of skeleton are wrong, and the thumb it's in the wrong place. So it took me much time to make it align perfectly. The second is the 3D data transform in the devices and across devices. It's a 3D transform matrix, so that can do a lot of calculations to make them collaboration in real time. So the next step in the future, the focus of this project is really on the education purpose. we have many collaborators in the education directions, in the anatomical education directions. And in this, as I mentioned before, we can do the multimodal interactions. We can use the context, use the video, use the virtual 3D models, and many control touch points that make students more engaged with the content. And then we can do the broader user study to improve the feasibility testing, so make it to spread its using situations, the scenarios. So that's the recap of this project.